In 2016, throughout the entire world, there was only 3 perfect papers on the for your spot. Well, on the whole test, I should say. And my guess would be that question 2 probably prevented a lot of those perfect papers. Um, the part B is pretty crazy, unless you know how to do some pretty advanced stuff with strings. So we look at number 2. Part A is pretty easy. We have to write a constructor. Simply have to initialize these 2 strings. Machine IDs, everything that comes before the colon. Descriptions, everything after. And they guarantee us there's going to be exactly 1 colon in this message. So I just used index of to locate that colon. And then I did 2 substrings, everything prior to, everything after. Make sure you know how substring indexes work, okay? How it's inclusive of the first number, exclusive of the second, and there's 2 different ways to use substring, right? If you just put 1 number in, it takes everything from that index to the end. So very important that you understand index of and the substring method. All right, so part B, this is a weird one. It says contains word, which that might seem easy, like we've done a lot of contains, we have the index of method available to us, but they throw a big loop here. We saw something like this in Magpie where we didn't want to detect the word mother within smothered, so we had to write like a find keyword method. And that's kind of like the inspiration for this problem. So for example, if you're searching for the word disk, you can't count disk 3 or diskette or slash disk or uppercase disk. It can only be this 4-letter word, lowercase, and there can't be anything attached to the front or the back of it. So if it's at the front or if it's at the back, that's okay. Otherwise, it's going to have a space on both sides of it. Now, when searching for those spaces, it's so easy to go out of bounds. And the way that you have to string together these 3 statements is really tough. Like if we wrote a big nested if, it would get pretty messy. We could do it all within one loop. I took a slightly different approach. So the way I did it here, and I'm trying to write my answer within the subset of our class. So I'm not using string methods that aren't available to us. There's multiple ways to use index of. And so if we step out of the subset of our course, which you're allowed to do as you write code, you can make this question a lot easier. But I'm trying to stick within just the subset of our course. So the first thing I did was I just looked to pass that test. Okay, so right here, if the keyword shows up, okay, then I know that this is going to work. Like I'm going to have a chance to be successful by their rules. Okay, so that's like my first piece that I want to satisfy. Now, once I know that that's true, I then thought to myself, okay, there's 2 more conditions that I need to pass. So what I'm doing is I'm referring to this one here as check 1, okay, and I'm referring to this one here as check 2. And I'm trying to verify that both check 1 and check 2 are true at some point. So for check 1 to be true, I either need the keyword to be at the beginning of the description. So that's pretty easy. Okay, if this would mean that the keyword's at the beginning of the description. If I just search from 0 to the keyword length, I find the keyword, then I can verify, okay, check 1's true. All right. The second part's a little bit trickier. The second part after the word or right here says that it's immediately preceded by a space. Now, this is tricky because it's very, very easy to go out of bounds here. If we are at the front of the string and we look to the left for a space, we're going to go out of bounds. And we don't know where this string is, and we can't really rely on index of because there could be multiple occurrences of it. Like, for example, right here, if you were relying on index of, you'd find this word disk, and it has a slash in front of it, and your method would return false, but there was a second occurrence of the word disk that you would have potentially overlooked. So we can't really rely on index of and writing that second piece there of bullet point 2. We're just going to have to loop across it. And as we loop, what I did was I said, well, let's loop, okay, just starting at index 1, which lets me safely look to the left for a space. But since I'm also searching for the keyword, then I have to be careful that I don't go out of bounds to the right as I start looking for a 3 or 4 or 5 letter keyword. So if let's say I'm searching for a 5 letter keyword, well, then I don't want to look too far to the right. So essentially, I want I plus the length of the keyword to remain in bounds. And so that's what this control here is giving me. So starting at 1 lets me look to the left at all times, okay, without going out of bounds. And stopping prior to the end of the string allows me to look far enough to the right for the keyword every time. If I get both of those to hit, then again, that's another way that check 1 can be true. So check 1's true if we're at the front of the string, or if we find the keyword and there's a space immediately to the left. Okay, so that's why I have 2 ifs. We have to find the keyword and verify a space is immediately to the left, and we can't go out of bounds. Very, very tricky, okay? Check 2 is real similar. The keyword's at the end of the description. So this time I just started at the back, the length of the description, and backtracked to the length of the keyword to create my substring. And if I found it, check 2 is true. Okay, so that highlighted code tells me that we found the keyword at the very end of the description. Otherwise, I have to find the keyword and verify that there's a space after it. So this time what I did was I started at the length of the keyword so I could backtrack in my search for the keyword, and I'll never go out of bounds that way because I always will have enough letters to go searching to the left if I start at its length. And then I said, well, I got to make sure I can always go up just past the length of the string in my search for that space character. Remember, substring lets you, it's weird, substring lets you go 1 past the length. It's different than array, okay? So substring lets you go 1 past the length without going out of bounds. And then, so now I can safely search for that space character there, and I'll be fine, okay? So if it's a length 10 string, I can safely substring up to 10. So, okay. And then if I find a space after the keyword, then I can say check 2 is true. All right, and then later I returned if check 1 and check 2 both came back to me as true statements. Okay. All right, so let's see what happens here. All right, and yeah, this looks pretty good. So I gave it 3 testers that were kind of like the ones in there, although I kind of messed with this one just to really even mess with you a little bit more. But yeah, so see how the first 3 had the word disk. Remember, everything after the colon is the description. So only the part after the colon is the description. That's what we see here. And then on the other 4, there was something preventing it. It could have been the 3, could have been the slash, could have been the word diskette. But yeah, those 7 cases are all showing up true. All right, you may have noticed I had a way different looking answer down here commented. And so yeah, if you were comfortable with some advanced string stuff, there's like a way easier way to do this problem. Okay, so something called string padding, which we discussed and we did with some Java bats, but I don't know if you remember or not. But yeah, to pad the string, we'll concatenate spaces on both ends of it. This is going to force us to find the string in isolation. There will never be a slash in front of it. There will never be a 3 appended to the end. It will never be part of the word diskette because we're saying there has to be a space on both sides. And the reason I did that to the description also is that way, if it is at the front or if it is at the back, I've allowed for a space character to be found there as needed. So this works as well. And obviously it takes a lot less code. I don't really know what the College Board's intent was here, to tell you the truth. I don't think they intended for kids to write this answer. Now, I don't know if they just overlooked the difficulty of this problem, if they forgot that kids don't know both index of methods, or if they just assumed that all kids knew how to do string padding. I'm guessing that's what it was, but that's definitely not true. Most students that took this test did not think of that, and it caused chaos, is my understanding. So that's a pretty wild problem there, part B. And then in part C, this is a remove method. So, I mean, we've done all this and we're still not even done. And it's got a twist in the sense that the removed messages, the ones that contain keywords, so we have to call that method from part B, in other words, the removed log messages have to be put into a new list. And that new list has to maintain the same orders. So if you were thinking you were going to do a backwards loop, you're going to have to be careful how you build that new array list of log messages. So again, this is another one of those ideas here where we have to use the method from part B. You can't avoid it, okay? So in my removal method here, another thing too is to note that they don't give us two array lists. They only give us one, and we have to maintain two lists, the one with the originals and the one with the removals. So first thing I got to do was make a brand new array list of log messages so that later I could return it. I did go ahead and write a backwards loop here just so you could see what I was referring to. And here I am calling the method from part B. So give me a log message from the list. I'll ask if it contains word keyword. If it does, I'm going to add it to my new list, and I'm going to do that by removing it from the old list, which simultaneously returns the log message that was removed, and I'm going to force it into the front. So even though my loop's going right to left, the removals are being forced to the left. So the later ones that I find actually show up in the front of the new list, and then as a result, it actually ends up maintaining the same order. So you can see here, I took the same 7 messages from here. So there's the 3 that were true. They were removed because they contained it, okay? And then here's the ones that were not removed, all right? And they are in the same orders that they originally were, okay? So pretty wild one. Okay, yeah, so that was a tough question. Like I said, if you have issues with it, let me know.